In this nugget, we'll walk through the solution for trouble ticket 14. In this troubleshooting ticket, PC1, which is right here, cannot ping the internal server, which is right here, when high availability has failed over. So in that case, what we're going to need to do to verify this is we'll have PC1 using a default gateway of 10.2.1.254, which is the IP address that's going to be supported by the active router for that HSRP group number 10. And we're also going to want to have the server use 10.2.2.254 as its default gateway, which is the IP address being supported by HSRP group 20 on the VLAN 20 subnet. So here's what I recommend. We'll set up those IP addresses. Let's do a quick baseline to see whether or not PC1 can connect to the server. And then what we can do is we can go ahead and fail one of these devices over to see whether or not it still works. And if it doesn't, which based on the trouble ticket it shouldn't, we can then go ahead and troubleshoot that. And because we are going to be using HSRP addresses for the default gateway for both VLANs, I would also recommend as a preemptive strike to bounce the VLAN 10 interface on DSW1 and the VLAN 20 interface on DSW2, because by default, those are the active routers for those respective HSRP groups. And based on the issue that sometimes but not always creeps up with HSRP in our topology, with our version of iOS that we're running, by bouncing those two VLAN interfaces respectively, that can help us avoid the additional troubleshooting step due to the HSRP active router not responding correctly. Here on DSW1, we'll go into configuration mode, we'll go into interface VLAN 10, we'll shut it down, and give it a few moments. And then we'll bring it back up with the no shutdown command, and then we'll go over to DSW2 and do that same treatment, but for VLAN 20. So here on DSW2, we'll go into configuration mode, we'll go into interface VLAN 20, and we'll issue a shutdown. And then after a few moments, we'll bring it up as well with a no shutdown command. So HSRP group number 10, the active router is DSW1, and the active router for HSRP group 20 is DSW2. And that's why we bounce those respective interfaces. Next, let's go to our internal server. This is the one on VLAN 20, and let's give it the IP address of 10.2.2.100/24 with a default gateway of 10.2.2.254, which is the HSRP address. And as a good measure, just to verify that the server can reach its default gateway, let's do a ping of 10.2.2.254. And survey says it looks pretty good. The first one could be due to an ARP request causing the first ping to time out. Let's hit the up arrow key and do it again. I want to make sure we get 5 out of 5. And that looks very, very good. Over on PC number 1, let's go ahead and give it an IP address with the command IP space DHCP using that syntax for the virtual PC simulator. And it's going through the discover, offer, request, and acknowledgement. And we've got an IP address of 10.2.1.6. And we've got a default gateway of 10.2.1.254, which is the HSRP IP address for group number 10 that's currently being supported by DSW1. And taking baby steps, we're going to ping 10.2.1.254 just to make sure that DSW1 is taking care of that IP address and responding on behalf of the HSRP group, which it is. So next, let's ping our server. Let's take a peek for a moment and see what that server address is. This is Zach on the server. It is 10.2.2.100. So from PC1, let's ping that IP address of 10.2.2.100, and we're hoping for success. And I have no success. Look at that. 10.2.2.100. Here at the very end, it snuck one in. What is that all about? So let's think together for a moment on what could have caused all those pings not to make it successfully. A couple of factors involved are this. We have PC1 and the server, which are both running the virtual PC simulator. And they have a very short ARP cache. I believe it's something like 2 minutes, 120 seconds by default, and then they forget. We also have our iOS multi-layer switches, DSW1 and DSW2, and they've got an ARP cache, and I think that's closer to 4 hours or something crazy like that. But initially, they're empty as well. And if we follow the packets involved, PC1 needed to use its default gateway, which was DSW1. So there's an ARP request there, and that would account for one ping not making it. Then DSW1, as it makes a forwarding decision and forwards it down to the server, it has to resolve the layer 2 address of the server, which is on the 10.2.2 subnet. That would be a second ARP request. Now, as part of an ARP request, we're also setting in the payload our own MAC address. So this server should automatically cache the layer 2 information in the ARP cache associated with DSW1's layer 3 address, which it very well could have done. However, that's not too useful to the server because as the server replies back to the 10.2.1 subnet, the server has configured on it a default gateway of the active router for HSRP Group 20. And that's currently being supported by DSW2, so there's yet another ARP request for its default gateway. And then DSW2, as it needs to forward that packet back to the PC, DSW2 has also not yet resolved PC1's address. DSW2 would also need to do an ARP resolution, and that would be 4. So based on this topology, and all the ARP caches being empty, initially, that would account for 4 packets that could have been consumed because the ARP process had not yet completed on each of those devices. So let's use our Star Wars motto of stay on target, and let's focus on the fact that PC1 now does have connectivity to the server. However, if we have to kick in high availability, meaning, for example, maybe DSW1 fails, then in that event, if we failed over, PC1 cannot connect to the server. Let's go ahead and verify that as well. So because it's been just a few moments, let me go ahead and do a ping real quick again. From PC1 over to the server, that looks good. Let's go to GNS3 and we'll completely power off DSW1. So here in GNS3, we'll right click on DSW1 and we'll simply tell it to go ahead and stop, which turns it off. So here at the PC, I'd like to just verify for a moment that PC1 can still ping its default gateway 10.2.1.254. And now that role of the active router for HSRP Group 10 is being supported by DSW2. So before we try the ping from PC1 over to the server, let's take a look for a moment at DSW2. He's complaining because he lost some neighbors. That was DSW1 because we powered it off. And here on DSW2, let's just verify that we can ping 10.2.1.6. And that was expected because PC1 can ping DSW2 or its default gateway being supported by HSRP. Next, let's verify that DSW2 can ping the server at 10.2.2.100, which it can. And here on DSW2, if we did a show IP interface for VLAN 10, if we were looking for anything that might prevent packets from being forwarded, we could look for things such as access control lists that would prevent, from an access control list perspective, traffic going from PC1 over to the server in VLAN 20. And we can consider that on 2 interfaces, the VLAN 10 interface of DSW2 and the VLAN 20 interface of DSW2. So we can take a look at the interface VLAN 20 IP information with the show IP interface for VLAN 20, and we can check the access control list there as well. Now, a couple other factors that we might want to consider. We might have VLAN access control lists, which are applied to the VLANs on DSW2 that were not applied on DSW1. We also might have port-based access control lists that have been applied that were present on DSW2 but not on DSW1. Another item we might want to consider is policy-based routing. If there's some policy-based routing in place that says based on these conditions, we're going to forward packets in a different location. If that's different on DSW2 compared to what was on DSW1, if DSW2 is in charge of the routing. However, the command show IP policy doesn't show any policy-based routing currently in place on DSW2. So the last thing for us to try is to go ahead and try the ping. Let's go back to PC1. And here on PC1, we'll use the up arrow key a couple of times. And we'll do a ping to 10.2.2.100. And survey says it is not making it. Now the virtual PC simulator is actually processing for us and showing us information that might not be available, for example, at a Windows computer. And if we expand the window here, it's showing us that the communication was administratively prohibited, meaning something killed this traffic. It's not allowed. Now we know the traffic is going through DSW2 because it's the only distribution layer switch left that we have. If we go back to DSW2 and we issue the command show access list, it can give us maybe an insight of what's going on. Also, somebody turned on logging on an access control list. So we have this really in-your-face log entry telling us specifically what happened. So this is saying list not set denied ICMP from 10.2.1.6, that was PC1, going over to 10.2.2.100. And here is the access control list. It's actually called not set, which is a really mean thing to do, because if you're looking at the access control lists that are applied to an interface with the show IP interface, it's kind of tricky to identify not set compared to not dash set, because they look very similar unless you're paying very close attention. So right here it says that line 10, which is the deny, had 5 entries that happened 5 times. And that's because we sent 5 pings and they were all denied. Now in our log message, notice this, it says it was only 1 packet. And that's because by default, a Cisco router or multi-layer switch, when it sees an access control list that's matched with logging, it's going to do a log message 1 time for that first packet. And then if we waited 5 minutes, it'll give us a summary for the balance of times it happened during that 5-minute interval. So this one packet is just the trigger that sent the message, but looking at the access list itself tells the true story about how many times that happened. So here on DSW2, if we do a show IP interface VLAN 10 pipe include list, here we can see the details regarding the access list called not dash set, which literally is set. So let's correct our access control list. We'll go into configuration mode. We'll configure IP access list extended not dash set. We'll say no 10 to remove the existing line 10, and then we'll do a show command to see the current contents of the access list with show space access list. And now we have a single line which says permit everything, which is just about as effective as having no access list at all. However, it does resolve the problem that we were having about PC1 not being able to ping server 2. I'd also like you to notice right here we have another message that indicates we had 4 packets that had been denied. So it triggered on the first one, mentioned it there, and then after a 5-minute interval, it gave us the balance. And if you're saying, Keith, it didn't seem like 5 minutes from the initial trigger, and that's because of due to a little bit of editing and background work that I do in the nuggets, the clock time was a little longer than the video time. So to test this, let's go back to PC1. And on PC1, we'll simply hit the up arrow key, do another ping to 10.2.2.100, and we're hoping for success. Now, it could be that we might miss a couple due to ARP, but then we have the results that are now pouring in. And now with the ARP cache is populated, we'll do a show ARP. And the same thing for our server, which also has an ARP entry. Let's go ahead and do the ping one more time. And we should get 5 out of 5, which is excellent. In this ticket, our fault domain was DSW2. The technology was access control list that existed on DSW2 but didn't exist on DSW1. And so when DSW1 was no longer available and DSW2 was doing the work, then the blocking occurred. And the fix, of course, was to modify the access control list on DSW2 to permit the desired traffic. Hey, thanks for joining me for this walkthrough for trouble ticket number 14. I hope this has been informative for you, and I'd like to thank you for viewing.